All right, folks. Thanks so much, Heather, and thanks for everybody for joining. I'm excited to be here on day two of Samvera Connect 2026. My name is April Rieger. I am the lead for the infrastructure team here at Notch 8. Excited to speak about our strategy that we use for mitigating AI scraping in our shared repositories in Hyku. Uh, so setting the scene, it could be a Monday morning. We're sitting in, meeting heavy Monday morning out of nowhere. We are getting site 24/7 notifications. We have multiple sites that are going down or slow to go down. Alerts are firing in Slack. We have pager duty going off. Either myself or my teammate Max are investigating what's going on. We're looking at the normal things. Traffic looks pretty normal. There's no recent deploys that would cause any outages. Infrastructure nodes are healthy. So the next logical step is looking at our shared resources, which we have Solr, Postgres, and Fedora, and they're all degrading at once. We're already in 15 minutes into this incident that's impacting multiple sites. And what we've found is that it's just one site being crawled. And this one site being crawled could be a legitimate crawling from Google being indexing our site, or it could be a bot. Most of the time, it's AI that's affecting everything, and because it's hitting one Haiku instance, it's affecting multiple sites. We've seen this, and it's a very expensive problem that we've had. Um, So when we've seen this, we typically think, oh, this might be a DDoS attack at first to glance, but with the traffic being normal, uh, the scrapers are targeting most of our expensive endpoints, which is catalog, which has the facets, the deep pagination, and it's very Solr intense. But also the work show pages, which trigger multiple backend calls, and then the uncached IIIF manifests or thumbnails, which are very expensive that generate the IIIF derivatives, as well as the download endpoints that we hit the storage and then the cluster's bandwidth. Um, and it leaves fewer resources for all of the different Haiku tenants that we have inside of the cluster. So we're seeing up to 20 to 60 time to first byte in the uncached request. Then we're using unique query strings every single time, and it completely bypassed caching. So even if we did have caching set up, it wouldn't have worked. It overwhelmed all of our shared resources like Solr, Postgres, Fedora, and the degradation on the front end for our users is real. They're unable to do any kind of searches, and it's impacting multiple sites. Back into 2024, this was pretty much every day. We were having issues in production sites that were starting to degrade. We're seeing a 91% uptime, 15-second response times, multiple critical outages throughout the entire day, which was a sustained performance degradation. So it's impacting our SLA times, all of our contracting to make sure that these sites are available. At the infrastructure level, each service begins to feel the pressure in a very different way. Solr is the first typically to struggle, gets killed. We have Postgres that falls with exhausting all of the connection pools. And then Fedora sitting upstream starts to fail because the dependencies are all slowing down. So now the entire backend stack is failing and under stress. And it quickly impacts to like the user impact because search becomes unusable, the collections are inaccessible, the public access is completely degraded at that time. So from a user's perspective, the system just feels really, really broken. And it's all just because of one tenant getting crawled. Um, so now that we've seen the impact on the systems, I wanted to talk about like what impact it has on us individually as the people that maintain them. Because it's not just about performance, it turns into like a real cost for the engineering and operations team. And we start getting multiple alerts across tenants at the same time. And because it's not isolated, you're not immediately pulled into an infrastructure level triage. The symptoms aren't always consistent either. Sometimes the sites and the resources are just slow, but some days they're down. And what we saw earlier, the root cause isn't always obvious at first. It often takes time and sometimes too much time to trace it back. What we've so what starts as a single crawler hitting one tenant turns into an hours of engineering investigation, debugging, recovery, and not just system degradation at that point. But hours spent chasing it down and fixing it, and often in a non-repeatable way, which is the anti-pattern that we're trying to avoid. Um, so what does this actually cost us as a service provider? On average, each incident takes about 2 to 4 hours to work through, from triage to identifying the issue and then deploying a fix. And that doesn't even include post-mortem or writing a playbook afterward. It's not planned work at all. And it's constant context switching away from priorities, improving the stack, client deliverables, and turns into a whack-a-mole. There's additional overhead from increased client communication. We're providing updates, managing expectations, and explaining what happens in real time. And over time, it starts to shift the conversation around scope because we're spending time reacting instead of building. So the takeaway became really clear to us that it wasn't sustainable with this change. We did try a few different approaches, but they weren't easy to replicate and they required too much manual intervention and investigation each time. So we knew a different approach was needed. We needed to move this problem out of the application layer entirely. And this is what it looks for us. Uh, it starts with the user and bot traffic hitting the public endpoints, things like catalog, workshow pages, and APIs. And that traffic is a mix of real users as well as scrapers. Instead of letting all of that hit our origin directly, we introduced an edge layer with Cloudflare's free tier. Um, this is where we apply protections like WAF rules, rate limiting, and bot detection. But just importantly, this is where we introduce caching. So for the anonymous traffic, we can serve responses directly from the edge, meaning that the requests never reach our application or the shared infrastructure. And for authenticated or sensitive requests, we bypass cache and send them through. So now we're not just filtering traffic, we're also reducing the load before it even hits our systems. From there, only filtering the necessary traffic, which moves to the origin through the load balancer, ingress, and then into the cluster, which means Solr, Postgres, and Fedora stays really stable. So the key shift here is that we're no longer reacting to the traffic at the application layer. We're controlling it at the edge. Our default posture when these things were going on is to go into the under attack mode, essentially challenging everything at the edge. It's a really blunt instrument, but it immediately reduces the pressure on origin. From there, we get more intentional. We only allow list things our clients actually need, like OAI PMH, stored, site 24/7 monitoring, search indexers. But even for all the allowed traffic, nothing's ever unlimited. Everything is rate limited. Everything's distributed across the edge locations, so we're not overwhelming a single origin endpoint. And wherever possible, we let caching absorb the traffic before it even hits the application. Then on the flip side, we block and challenge what we don't want. That includes AI crawlers and aggressive scrapers that are driving the kind of load we just looked at. So the goal isn't to shut everything down, it's to allow what's necessary and control the rest. Everything we've been doing with Cloudflare has been defined in infrastructure as code. We're using Terraform and OpenTofu to manage these rules. So it's not just manual clicking in the UI, it's a repeatable process, it's versioned and deployed across multiple environments. The pieces that we have are skip rules, which We're not blocking the legitimate traffic like OAI endpoints, the monitoring, or our static assets. We want to pass those through cleanly. Then we have block rules. This is where we shut down all the bad paths, things like a WP login, admin, the cron endpoint, and stuff bots that are constantly probing and are visible through our Cloudflare analytics. On top of that, we apply a managed challenge on catalog, and this is one of our most expensive endpoints. So instead of letting every request through, we force some kind of verification before it hits the origin. We also introduce rate limiting, roughly 10 requests per second. That's enough for the normal users, but it really helps with slowing down the aggressive scraping behavior that we see. Bot fight mode is also enabled. That's one of Cloudflare's behavioral detections. It evaluates the traffic that actually behaves, that the traffic actually behaves and not actually claiming what it is, because good bots can also wear disguises. And finally, caching. We're using tiered caching, both static as well as dynamic, and we're making it cookie aware so authenticated users bypass cache while anonymous traffic gets the performance benefit. Just to reiterate, this isn't enterprise tooling. This is all achievable under the Cloudflare free tier, and it's enough to significantly reduce the pressure we're seeing on Origin. So it isn't pretty. You know, when we first implemented this, we were getting a lot of client calls about, hey, I'm unable to get my OAI or my SAML or Sword to work from backend API calls. So there were a lot of gotchas that we learned along the way. One of them is don't allow listings like OAI or SAML. You can end up blocking your own integrations. The JS challenge for breaks the background processes like IIIF and OCR, because those systems can't pass the challenge, of course. You have lesson three is you have to match the cache behavior to your origin, and you must bypass cache for authenticated users. Otherwise, you risk leaking or mixing the user state. Lesson four, we hit limits on the free tier. They have 10 cache rule cap. So we had to be very intentional on how we designed that. All of this to say, nothing's ever perfect. We can't plan for every edge case. So this is one of those things where we're constantly iterating and pushing out new code. The results that we've seen and that we've been really happy with is that, you know, we haven't seen a cluster-wide bot-related outage in over 6 months. That alone's a huge shift. Uptime's back to 99% from 91%, and we're consistently stable now. One of the biggest improvements is the performance. Catalog responses are being served from the edge in under 100 milliseconds, providing a completely different experience for our users. Up to 50% of the incoming requests that are identified as non-human or abusive are mitigated at the edge. Because of that, we're seeing fewer client escalations and nearly zero bot-related on-call pages. If you can remember three things: first, control the traffic before it hits your origin. Once the requests reach your infrastructure, you've already lost some level of control and cost. Second, move the fight to the edge. That's where we have most leverage to filter challenges and absorb before it gets to become a real problem at the infrastructure level. And third, putting it in code. If it's not in code, it's not easy to repeat. And if it's not repeatable, then you're going to find yourself solving the same incident over and over again. Um, Infrastructure as code with the Cloudflare IAC has been a huge game changer for us at Notch 8. And we went from being reactive firefighters to something more sustainable. Edge plus infrastructure as code gives you a model where you can respond quickly, apply the changes consistently, and scale across environments without introducing unnecessary risk. And that's what you get. That's what you get out of the whack-a-mole cycle. I wanted to offer up to the community a free open source version of our setup with Terraform examples. It's at the GitHub repository list here. You can also scan it, the QR code, and it'll lead you to there as well. And I wanted to pause for a second and ask if there are any questions, and thank you all for having me.